again. So till now what we have understood is about evaporation. Yes, we have understood what are the factors that affect the rate of evaporation. The next topic which I am going to discuss today is cooling caused by evaporation. Right? So what do you mean by cooling caused by evaporation? To understand this topic much more, you have to understand the examples. Okay, so whenever a liquid evaporates, it must be supplying some amount of latent heat. We have understood about the concept of latent heat. So the cooling caused by evaporation, it is actually based on the fact that whenever a liquid evaporates, what happens? It draws or it takes the latent heat of vaporization from anything which it touches. So whenever it loses heat, so what will happen? It will get cooled. Keeping these points, so you just think of some examples which we will be discussing. So cooling caused by evaporation occurs in our day-to-day life every day. So we are not aware also, but still this is happening in our day-to-day life. So this is an application-based concept that you must understand. I'll give you many examples as such. So first, the best example that you can give here is about sweating. Yes, so we all sweat. Yes or no, during hot summer days. So what happens? Why sweating occurs? The best example. So on a hot day or even after doing some physical exercise, when our body temperature tends to rise too much. So what happens? Our sweat glands, they give out the moisture which is called as sweat on our skin. Now, this is a perfect example to understand evaporation causes cooling. When this sweat evaporates, it takes the latent heat of vaporization from your body, and so as a result, your body feels cool. Am I clear? So it takes away, by taking away the latent heat which is inside your body, it makes your body feel cool. So this is one best example. Next, there are so many other examples given in your book. Already in the previous class, while discussing about latent heat of vaporization, I have given the example of sanitizer. I have given the example of ice. Do you remember? Yes. So similarly, there are a few more examples which we will be discussing during hot summer days. Yes, water is kept in an earthen pot. So usually in villages and all, we know this water which is kept in a matka. Okay, matke ka pani bolte hai. Yes. So how is it cooled? So if you have to understand this, the earthen pot, have you seen the earthen pot? All of you. So it has very few, what you can say, small size holes or pores in its wall. So this water continuously keeps seeping through these pores to the outside of the pot. And when this water evaporates, that means it changes into vapor, it takes the latent heat of vaporization from the earthen pot, and the remaining water as such becomes cool inside. So as soon as the latent heat is released, it makes the water inside cool. So this is also one example of the cooling caused by evaporation. So please remember, these two examples I have given you. There are many more examples. Perspiration I have given you. Again, one more thing which is very frequently seen in villages. Okay, what do people do? They sprinkle water, okay, on the ground in front of their homes, and also even on the rooftops. You must have seen people sprinkling water on the rooftops or open ground. Have you noticed that? Right. So why do we do this? Okay, what is this practice actually? Actually, what is happening, by sprinkling water, we are releasing the latent heat from the earth, and as a result, after the latent heat is released, it makes the hot surface cool. So this is why latent heat is released and it has a cooling effect on us. Similarly, cotton clothes. We all wear cotton clothes, okay, in summers. So why do we wear cotton clothes? Of course, in class 7th you have studied this, right? You have understood that by wearing cotton clothes, it absorbs the sweat and the sweat evaporates, okay? But you must also remember sweat. So it makes us very uncomfortable, especially if you don't wear a cotton cloth. Suppose you are wearing nylon cloth, okay? Nylon does not absorb the water. So as a result, the synthetic clothes, they do not absorb much amount of sweat also. And so they fail to keep our body cool in summer, okay? So this is the reason we should wear cotton clothes in summer. Similarly, a desert cooler. Now see this example. This is also mentioned in your textbook. The desert cooler works perfectly on a hot and dry day. Please understand this 2 point, hot and dry. Why? Because, see, again we go back to the factors affecting the rate of evaporation. Okay? So, higher the temperature on a hot day, the more will be the rate of evaporation. Similarly, the lower the humidity, the more will be the rate of evaporation. So these two factors, considering these two factors, we can understand this point very clearly, that a desert cooler works much better on a hot summer day than on a, what you can say, if it is a rainy day or if it is a cold day. So generally these desert coolers are much preferred in the northern part of our country. We do not, here we use AC for cooling and all, but we do not use cooler here. Okay, because humidity, as you know, is much more, and this desert cooler does not work better if there is much amount of humidity in the air. So this is one more example. Another example, again, if you see, we are suppose you are in a hurry and you are supposed to sip hot tea or milk, okay, or any other, suppose hot, any other substance. We are supposed to drink from a hot cup of tea. What do? You pour it on a saucer. So why do we do that? Saucer has large surface area. As a result, rate of evaporation is faster. So this is also one more example of how evaporation causes cooling. So students, all these examples that I have given right now, these are the examples from your everyday life. We are discussing the examples from your daily life where evaporation causes cooling or evaporation has a cooling effect. So in today's assignment, I have given you one question where you have to write about how evaporation causes cooling with some examples from your daily life. Now please remember, for these examples you are going to write the examples along with the proper explanation. What children do is they just write the statement that this is on a, we sprinkle water on a hot on the rooftop during a hot day. So don't write only the statement. I want a proper explanation also, how the latent heat. Please mention the role of latent heat. Okay, if you don't mention the role of latent heat there, your answer is incomplete. I hope you have got it. So this is all about evaporation and how evaporation causes cooling. Next, there is a very simple activity which you must have done in your lower class, okay, to show the presence of water vapor in air. Okay, now this is a very simple activity. For this activity, we need the following. We need a steel tumbler, and what do? We put some well crushed ice into it. Then we wipe the tumbler with a cotton cloth to make the surface clear and dry. So I hope by seeing the picture in the slide, you remember that you have studied this in class 6th. Okay, so go through this. Yes. So what is the observation? You allow the ice tumbler and to cool it for 5 minutes, leave it undisturbed. What will you observe? Of course, you will observe a large number of tiny droplets of water which appear on the outer surface of the tumbler. Now, why do we see this tiny droplets of water on the outer surface? The question is this, right? So this should be there in your mind. Why? From where do these water droplets come? So this formation of water droplets shows the presence of water vapor in air. Now this, when the air around the steel tumbler, reason it is given here, the air around the steel tumbler contains water vapor. You can see this. When this water vapor comes in contact with the cold surface, outside surface of the tumbler, condensation takes place. You know what is condensation, right? So they condense to form these tiny drops of liquid water. So this is the reason this activity proves. This activity is a very simple activity to prove the presence of water vapor in air, because initially there was no droplets of water. So from where these droplets of water have come? These droplets of water that you can see here right on the outer surface, this is because of the presence of moisture or water vapor in the air. So this is a very simple activity. You can write in your own words. Okay. So now what we have understood through this activity, the presence of water vapor in air. So after this, till now we have understood about the three states of matter, right? In the beginning I told you that, not this video, in the previous video only I have discussed that till now we know that matter exists in three states: solid, liquid and gas. But is it so? Now we have come to the conclusion part, and here we now know that there are five states of matter. The fourth being plasma, and the fifth being Bose-Einstein condensate. We also call it as BEC. Bose-Einstein condensate. Okay, so we have discussed about solids, we have discussed about liquid, we have discussed about gas. We know their comparative properties, right? You are in a position to easily distinguish between solid, liquid and gas. Now we will discuss today the fourth state, that is plasma, and as well as the fifth state, that is Bose-Einstein condensate. Right. So here in the slide also you can see, just have an idea. Solid, you can see the picture of the solid, you can see the picture of liquid. Gas, so you all have seen. Now your query is about fourth and the fifth, plasma and Bose-Einstein condensate. So what is plasma, right? Okay, the fourth state of matter. Plasma is considered the fourth state of matter. So plasma is actually a mixture of free electrons and ions. Now what are electrons? Electrons are negatively charged particles. In the fourth chapter you will come to know, when you study structure of atom, that electrons are negatively charged particles, and ions are of course the charged particles. They may be positively charged, they may be negatively charged. So plasma is considered the fourth state of matter. Generally plasma occurs in the stars, okay, including the sun. You can see in the picture. Okay, inside the stars the temperature is so high that the atoms break up. So some of these electrons, they break away from the atoms, converting the rest of the atoms into electrically charged particles, which are called as ions. So generally what happens, this mixture of free electrons and ions, the mixture that you can see of free electrons and ions together forms the plasma. Okay, so first thing you have to understand that plasma is a mixture of free electrons and ions. What are ions? Ions are charged particles. Am I clear? So this plasma, it is present inside the sun. Here you can see lightning. During lightning, a huge amount of energy is released. I hope you remember class 8th. Yes, so during that, the particles, the charged particles, they are nothing but the fourth state of matter, which is called as plasma. So plasma is actually it is present inside the stars, and it is also because of this plasma that the stars glow. Okay, so more examples I'll be giving you. You can see here the neon lights. So if the neon lights are made of plasma, this must strike to your mind that this plasma can be made on the earth or inside the lab also. Of course, plasma can also be made on the earth by passing electricity through gases at very low pressure taken in a glass tube. This is also called as a discharge tube. Again, the presence of electrons, protons and all, during that part study of that chapter 4, we will again discuss about discharge tube. Okay, so the fluorescent tube and neon sign bulbs from plasma when they are switched on. Similarly, you must have seen the traffic policeman. Have you seen the traffic policeman holding a baton type, light type structure to stop the traffic or regulate the flow of traffic? Have you noticed that? So that is also made up of plasma. Nowadays even the plasma TVs are also available. You must have seen in the market. Yes, so this plasma is nothing but it is the fourth state of matter, which is an ionized gas, a gas into which sufficient energy is provided so as that they become free electrons, okay, from atoms or molecules. And also remember, this plasma is nothing but it is ionized gas, which is present naturally also, which can be made artificially in the lab also. So naturally, example, inside the sun and all, But artificially you can give example of discharge tube, okay? You can give example of neon lights. So all these are examples of plasma. So now do you understand, do you find the justification why plasma should be considered the fourth state of matter? Why can't we put it in solid, liquid and gas? Do you think they will find a respective place in solid, liquid and gas? No, they will not find a position in solid, liquid and gas. Why? Because these are ionized gases, okay? These are ionized gases, mixture of free electrons and ions. And so they have been made and put in a separate way, and that is the fourth state of matter. Okay, so now I'll go to the last state of matter, which is your BEC or Bose-Einstein condensate. So in 1920 actually, an Indian scientist by the name of Satyendranath Bose, he did some calculations for the fifth state of matter. Okay. Now what was the basis of this calculation? Actually, on the basis of this calculation, actually Albert Einstein predicted the existence of a new state of matter which is called as the BEC, Bose-Einstein condensate. You all have heard about Albert Einstein, right? So the fifth state of matter, which is called BEC, it was finally achieved in 1995 by the rest of the scientists, that is Cornell and Wieman, which is given here. Okay, the existence was discussed in 1920s. Please remember, it was way back in 1920s that this existence of fifth state of matter was discussed, but because due to the lack of advancement in technology, you can say, or due to the lack of facilities available at the time, it did not somehow happen. But in 1995, the scientists Cornell, Catley and Wieman of USA, what they did by cooling a gas of extremely low density to super low temperatures. Now see, if plasmas are super hot, this super hot what you can say ions, free electrons and ions, right? Because they are present inside the star. Just the opposite of plasma here is BEC. So these are totally opposite. They are super unexcited and they are super cold atom. That is the reason the two scientists, which by the name of Cornell and Wieman, they created this new state of matter. How did they do? By cooling a gas of extremely low density. So about almost if you say 100,000 the density of normal air to super low temperature. Now this state of matter is absolutely a new addition to the crew. That means already we had studied about the four states of matter. Now we come to the conclusion there is also a fifth state of matter which is called as BEC. It all starts when the atoms start to get cold. You can see here, when atoms are really cold, okay, they get closer. You can see when they are cooled down to extremely low temperatures, they come closer and they begin to form a clump. Okay, when the atoms clump up, they become one big blob that all of them looks the same. So this is also called as BEC or Bose-Einstein condensate. So if you have observed this carefully, this is how this BEC looks like. Okay, so this is only for those gases which can be cooled to super low temperature. Am I clear? Okay, so this is all about the fifth state of matter. So with this, the chapter is also over. If you have any doubt, we can also do a recapitulation. So important questions, of course, characteristics of matter, you all have written. Then terms relating to this chapter like evaporation, sublimation, so many terms are there. Melting, melting point, right? Next, we have discussed about latent heat, right? And latent heat of vaporization, fusion as well as vaporization. We have come to know about evaporation, factors affecting the rate of evaporation. So before I stop this class of today, what is my intention is, you have to go through the whole chapter, read the chapter. I have simplified it and given you in the form of notes. Okay? From the starting class only I have given you notes. Now your duty is to keep the notes ready, study, revise, learn the concepts, and along with that, what you have to do, is the in-text questions. Now see, in-text questions, I believe 2 pages you have done. I don't remember exactly the page number. Page number 10, there are 5 questions which are based on evaporation, cooling caused by evaporation. Please do those 5 questions also, as well as the NCERT textbook question, which is there in the text chapter and question. Yes. See, there are 2 types of questions you are getting. One is in-text question, another is chapter end question. In your copy, I repeat, in your classwork copy, chapter end question must also be there, as well as in-text question must also be there. This is for chemistry as well as biology as well as physics. So please remember, yes, of course, you are doing the in-text question as well as the chapter end question, right? Now, one more thing for today's assignment. For today's assignment, I am not going to give you any question from the chapter or the textbook. That you will be doing it and showing it to me or the respective chemistry teacher on the first day when the school reopens. Okay, so that is your part, but as an assignment, I have given you 2 questions today. Okay, the first question is you have to discuss or write a short note on the 4th and the 5th state of matter, right? So that means you have to write about what? You have to write about plasma and you have to write about BEC. Next question, you have to give 3 examples, as I have already mentioned, 3 examples of application, that is application in your day-to-day life about evaporation that leads to cooling caused by evaporation, right? So this is all about this chapter. So with this chapter is also over. Now your duty is to go through the chapter, by heart the points, and then you will be able to master this chapter. Very easy. So this is of course a very important matter because it is of course related to matter in our surroundings. So now with this I come to the end of this presentation, and the next class I'll start biology chapter 5, that is fundamental unit of life. So be prepared for that. Thank you. If you have any doubt, you just feel free to call me or you WhatsApp me. As I always tell you, you feel free to call me or WhatsApp me whenever you any case of doubt or any doubts are there in your mind, right? Thank you.